I'll be talking about how you can composify your not compose code, meaning libraries that are fundamentally incompatible with compose or they look very hard to integrate, and how can we provide an interface for them so we can integrate them in compose code from a non-compose perspective. I will be showcasing the Android Maps Compose library, which makes a very good job at this. It's if you have been using Google Maps, it's a library that has like a view class or an XML, and well, Android Maps Compose bridges the gap, so you can actually use this library from a Compose application. I guess most of the people here knows about Compose, the XML world, how was the transition, the problem that one approach was trying to solve. And well, in Android, since pretty much the beginning, we had an imperative approach, which was this XML-based system. How we built the UI was by creating XML layout files and managing their state programmatically in an activity or a fragment. We could call set functions to change the state and modify the properties, or a view class if, in the case, we're not using an XML. And well, this worked until it didn't work, I guess. And it started leading to, well, more of a complex state management, boilerplate code. And today, the Compose, the declarative approach is the industry standard. You can see the same in Flutter. You can see the same with Swift UI. So this is where the world has been heading. Yeah, something like this. This is probably familiar to many of you. We just have like an XML file with this tree structure that gets loaded from our main container, fragments or activities. Now, Jetpack Compose, it's a toolkit that has been designed to simplify the UI development. What we do is we're not programmatically changing the state, but we declaratively implement how the UI is going to look like for a given state. We have a lot of states, and in Compose code, we have, well, basically associations that represents, okay, if we have this state where, for example, the list of items is empty, we are going to be displaying this different UI. We are going to be taking this entity, analyzing it, and then based on that, drawing different components on the screen. The theory of this is that simplifies the development and reduces bugs. Of course, normally I try to prepare my slides the night before the conference so I can be more stressed, but this time I finished them way before the conference. So it's the last time because, of course, the Google I/O was 2 weeks ago or 3 weeks ago, and they announced that Android is going to be composed first. So just so you know, now it's been for a while unofficially, I guess, but now the official stance from Google is that Android is composed first. I think they state something like, we'll keep supporting XMLs, which means that they're going to kill them very soon, I guess. And yeah, this is our hello world in Compose. We just have a composable annotation function that contains some Compose primitives, in this case, a text. And this is what you get when you create a new Android application in Android Studio. Of course, this works for a very simple theme, but as we know, the code base tend to get more complex over time. And there is also an interoperability challenge. Many Android apps are not greenfield projects. Right now, for example, I'm working on a code base that might be like 10, 12 years old. Always with the resources you have, sometimes it's hard to say, let's replace everything. You need to keep the old things running. So it can happen that you need to interoperate with an existing code base that has been written using XMLs or the traditional views, because for any reason, you don't have the capacity to rewrite everything. So one of those libraries could be the Google Maps SDK, right? It's a huge monolith, native views, C++ rendering. I guess Google doesn't have the capacity to rewrite everything. We have other types of libraries. I'm sure you have been working with UIs that are very complex, are rendering on the canvas, and well, it's not feasible to get them a rewrite. So in this case, how can we integrate a view, a traditional Android view, into a composed UI tree? Well, the official answer to this is the Android View Bridge. The Android view is composable and is the interoperability solution from the Compose team. It's basically a container where you can have an old school Android view and start operating over this Android view. In the case of Google Maps, you might have used it, and you probably see that you have things like set these, I don't know, these listeners. You need also to manage the life cycle. You might need to be changing some properties based on some interactions. But Compose operates very different from how views work, right? So we cannot take a composable and do something like compose dot add this thing, because it doesn't work that way. So we need to start prepping our app, our library. How the Android view works. The Android view, it's a composable, and it's going to take a few lambdas where we can start adding our juice and our sugar. One of them is the factory lambda that we use to create the view. We have an update lambda that we use to reconfigure the view itself every time there is a recomposition. So if there is a recomposition, we have new state, and we might need to change the view, right? Change background color, change dark mode, start adding, in the case of map, well, we have markers, but there are different libraries that, well, might have different requirements. The factory is called only once when we create the view instance. So sort of a onCreate method for the view, right? And now let's start adding things step by step. This could be a very first simple approach. We have our Android view with a factory method, a factory lambda, that gets called only once when the view gets created. And we have the update one, which is going to be called every time there is a recomposition. So in this case, again, this is an imaginary view that we have. It's not very complex. The only requirement we have is that we need to change the text based on an external state. But again, for a simple text view, everything works for simple solutions, but software tends to get complex over time. And so it's map view, for example. In the case of map view, we have the life cycles that need to notify the host life cycle to be able to initialize properly, to wind down every time our activity is closing. We have this map.onCreate, map.onResume, many different methods that is not just going to work if we grab the map in an Android view and forget about it. So let's start deep in, how does the AI say, delving into this problem. So yeah, a first problem is that we need to forward the lifecycle events. The map just cannot hold them. It needs to tell the activity or the fragment that, hey, this event happened and we need to do something. If you don't do it, as you know, you're going to have memory leaks, or the application is going to crash, or the map will not be initializing. So moving one step forward. On maps, before the compose world, this is what we used to do. We used to have an onCreate method, right, in the activity, an onResume method, onDestroy method, etc., where we needed to initialize our view. This worked very well, but on the compose world, we cannot like save the composable and start doing things on Resume. That's not going to work. We need to fix this problem. So yeah, we cannot redirect it directly to the fragment. We need to access the parent composable lifecycle information from within the composable. And yeah, there needs to be a way to observe the lifecycle of the composable. The way to do this could be using a local lifecycle owner, which is a composition local that returns as the current status, the current lifecycle of the application. With this, we can see what the activity or the fragment is doing from any composable in the composable tree. And we call it like this, within a composable context, but by calling local lifecycle owner.current.lifecycle, we're able to get it and start operating over it. The map view needs to be careful about this. So it needs to check what's the current status. You also need to make a little bit of safety checks and guardrails about, am I moving from one status into an allowed one? Can I jump from onDestroyed into onCreate, onCreate into onDestroy? These sort of things. So yeah, this needs to be carefully managed. Only when the map view is actually attached to a window, if you let the composable without being attached manage all those things, there are also some crashes that you might have. That's something that I think is also hard to see until, well, the architecture is done. But, well, it's not so simple as just doing, like, hooking it up. It needs to be done at a few places. So this my life cycle event of server is going to become a state machine to make sure that all the calls that the map view is doing are going to be done in the correct sequence. So yeah, a bit more of code. This is actually the real code from Android Map Compose. You can see that we have here the factory method that we saw in a very basic example at the beginning that receives context as a parameter. And context is something basic for every view, right? Every time we initialize a view, we need to pass the context because the view might need to add some resources or some information from our Android context. This is actually the view constructor, the one that we would be calling from a standard view or XML world. And here we're passing the Google Maps options factory. Here, this is just a default method that we use to initialize the Google Maps options by default. Things like, am I using dark mode? Am I using, I don't know, certain properties of the map? And here we get a view. This is a standard Android view. Things that we need to do on specifically in a Google Maps, but different libraries might have different requirements, is that, for example, we need to have some component callbacks, right? This is something that you call on maps if you want to operate when the configuration changes, when the memory is low, or when the memory is being trimmed. Again, this is something that on view world you might have been doing on the onCreate method. So here you just do it on the factory method. And yeah, from the callback on trim memory, for example, you call the map view dot on low memory. There is no on trim memory, so here we just call this one. And here we start to call the lifecycle observer that we mentioned before to start dealing with the lifecycle. So what we have here is some callbacks that we need, or some listeners maybe in another view. We register them in the context or whatever we need to do them, and now we start to manage the lifecycle. For the maps, this is also something maps specific. Is that we need to provide a tag. The tag allows you to uniquely identify a map in case you have like different maps in a list or in different sections in the screen. And here we start operating with the lifecycle. So we are going to use this view, which is again a view-specific method on attach state change listener to be able to identify when the map is being attached to the window. Before it gets attached to the window, we don't need to operate with it. So here we initialize the lifecycle to the find view tree lifecycle owner from the map view. And when the view gets detached from the window for whatever reason, this is, again, a view method. We remove the observer that we had on the lifecycle, set it to null for safety, and move the lifecycle observer into the base state. And yeah, so let's see here a few more methods. We have the onRelease method. This gets called when the composable gets killed. In this case, we are doing also some deinitialization and null setting on some properties from the map. The tag, for example, is null because it has been released. The lifecycle observer is going to be moved to the destroyed state. That's the on destroy, basically, in the lifecycle. We unregister the component callbacks, etc. And we make sure that there is not going to be any memory leak. This is what you would be calling in the on destroy method, probably in Android, to make sure that the library, the view, is not in memory. And update, this is what we call every time there is a new recomposition. Every time Compose identifies, something has changed in my state. I need to change something on my library. What we have here is a launch subcomposition. We'll see now what is this extension function, where we are passing some parameters that we need: the updated state, parent composition, the map view, the listeners, and the current content. This is this launch subcomposition extension function. This is an extension function from the coroutine scope that is basically starting a coroutine and starts doing the map initialization that we need. Here we call the await map, the same way we would call it on a standard view. And here we would initialize a composition using the parent and this map applier from here. The map applier is a very simple internal class. It just receives the Google Map class to operate with it, the map view. If you have been using maps, those are the different classes that serve different purposes. and the map click listeners. Everything that happens when you click on the map, drag on the map, long click, take your finger out, etc. The appliers in Compose are a vital part of doing some customizations with Compose. So here what we take is the current composer.applier as a map applier, but the map applier is an abstract applier in Compose. An applier in Compose is a central class that has the responsibility of inserting nodes into the Compose tree, removing nodes from the Compose tree, in general, modifying the Compose tree every time something needs to change. So in the case from maps, we would have things like, okay, we are inserting markers. Then the applier needs to go into the Compose tree and identify what it needs to add. And in this case, it would add a marker or remove one or replace it. So it's basically an applier or a drawer inside a tree. Now, we have done, well, we have started to connect our lifecycle, but we're not quite finished there. We have initialized with the Android view the map, but we need to start doing more things. Now, we've seen a bit of the map lifecycle event observer. It's not just a when that correlates internal or compose lifecycle with the view one. It has certain safety mechanisms or a more robust pattern to make sure that the transitions are happening properly. So you cannot move as you have in this Android lifecycle diagram. You need to move from on create from on start, for example, on pause on stop. You cannot just skip states as you want. So these just provide a little bit of safety. This is the implementation of the map lifecycle event observer, which takes the map view, the view class. Here we take the lifecycle as initialized, the current one, and start operating with it. This is, by the way, overriding the lifecycle event observer. This is a class that allows you to observe the lifecycle and implements a few methods. One of them is the on-state change. This gets called every time the state has changed. And we get, well, the most relevant one is the new event that happens. So here what we do is, okay, if this event is on destroy, we are going to move into the base state. And if not, we are going to move to lifecycle state. Move to base state is simple. It just checks that, okay, if the current lifecycle state is at the top of created, we move back into created. So if it's created, it doesn't do anything to avoid, well, weird behavior on the lifecycle. Yeah, move to destroy the state. If the current lifecycle state is bigger than initialized, then we can move it into destroyed. And the general move to lifecycle state takes the target state and makes a basic compromission here. If the current one is different than the target one, then we are going to move up or down depending on the position where we are on the tree. This is, by the way, an enum. I didn't know it until I started checking the implementation. All these states, which, well, I guess is not super comfortable to deal with, but as they say, it's not the future we need, but it's the future we have. And well, move down or move up are basic functions from the lifecycle.event. You can call the down from, you can call the up from. You have some error handling just to, in case the state that you're proposing is not right, and you invoke the event. Invoking event is where the mapping happens. This is a function that takes the current lifecycle event that you're trying to pass, and based on it, you call the method that you need on the map view. So if the onCreate has happened, the composable internally is going to call the map view.onCreate, passing a default bundle, the same for onStart, onResume, and so forth and so on. And yeah, now we have a bit of safety on our map view. So the map view now is integrated into a composable. We have the Android view bridge. We are able to initialize it. We're able to destroy it. The lifecycle is being respected, so everything gets notified into the parent composable. It will not have memory leaks, and it will not crash. But as you know, this might not be the first step. This API is still very low level for a good developer experience. And maps, it's more complex. We need to add things like markers, polylines. We have many other operations, move the camera, etc. So we need to build an idiomatic API. A compose API, an idiomatic compose API, needs to be declarative and state-driven. If you develop APIs, it's actually really nice because Google has a Compose API guidelines that, well, it's very, you can Google something like Compose API guidelines and API guidelines for Jetpack Compose exactly. This is maintained on the Google source website, and well, it's very vocal about how an API for Compose needs to be designed. So it talks about you need to have first a modifier parameter that has a default value. You need to call the functions in a specific way. You need to group properties instead of having many different parameters, because then it's going to grow, providing a default value as much as you can. And but yeah, generally our users, the users of the library, should not be thinking about things that are not Compose specific, right? So we need to keep adapting our interface for them. So let's see the declarative versus the imperative. The old way, the imperative, would require us to call a method to change the UI. In the case of the camera in Maps, it could be something like map.animateCamera or map.moveCamera. In the declarative, the new way, we change the state, and then the UI is going to react accordingly. So what we would have is Google Map that receives maybe a camera position state. We just modify this position, and Compose does its magic. The user does not need to be forcing anything artificially. So camera position state, for example, I think it's a good example, is a class that is going to be holding the current camera state. We know that a camera might have position, zoom, it has the reason to be moving, whether it's currently moving or not. So it's basically a state holder that has been a little bit composified. This is how an API for Compose could look like. We could have the something called the remember camera position state, where we have a few attributes. Position could be one of them. And by using this remember camera position state, we hook it up automatically into Compose. This, if you have been using Compose, you know we have this remember and many different remember functions. The remember camera position state itself is not very magic. What we have is a key and then a camera position state here. And by using remember savable, we just call this apply camera position state. The remember savable receives a key and a saver, but this was recently deprecated. So the key in Compose, this parameter from here, is not required anymore. It was removed in, I don't know, one of the, a few months in one of the new Compose versions, which I think is also relevant of how much of an eye we need to keep on the Compose changes. We are relying on a toolkit like Compose, so every time there are new changes, new releases, this might break or change things. So there is certain maintenance obligation when you are relying on Compose. You always need to reflect the underlying framework. Exactly, this remember savable. So this makes sure that changes into this object are going to be triggering an update in Compose. Inside the camera position state, we have also a few Compose-specific camera specific fields. By default, we have the camera position initialized to everything 0. We have the is moving attribute, which identifies if the camera is currently moving or not. We have the reason to move the camera, same as in Google Maps, whether there is no movement yet, or the user initialized it, or is moving because the new location is requesting a camera change. And something interesting still in this camera position class is that we have access to the current Google Maps, the map that is currently associated with the camera position state, and we are locking it here to avoid like multiple accesses to the same map and making it more safe to avoid that the camera gets moved due to independent calls. We synchronize here the set map based on the map that we have extracted. We only associate it with one Google map at a single time. This is to prevent that if the map is being called in a list as we are scrolling, different cameras state can affect different maps. So this needs to be univocally connected with a single one. And well, this is also here a simple compromission. If the map is different, it's null, then it's not moving. If not, we just move the camera with the view system, with the view approach, map.moveCamera, instead of doing any Compose thing. But this allows us, from the Compose perspective, to just hook up the camera position state. And well, every time the maps change, we just call the onMap change log to clear it. This is the same one-way data flow that we follow in Compose. The developer only changes the camera position state. It doesn't need to do anything. It doesn't need to go into the internal of Compose. The Google Map composable is going to find out that, hey, this camera position state that I have above has changed. So I'm going to call the move camera on the underlying map view. The user doesn't need to access the move camera itself at any point. Of course, we have user interactions. So when the user drags the map, as you do on a map view, the map view is going to fire a callback. The library code is going to listen to the callback, and is going to update the camera position state to reflect the new position. Now, one more thing that we need on this type of libraries. These Android views use listeners to interact with external events like set on map click listener or long click, etc. But Compose uses lambdas passed as parameters to the composable. It doesn't call listeners. We also need to make a transformation between them. So on Google Maps, this is how it would look like. We could have a on map click, as we see here, that receives the lat long object. In this case, we're just creating a log. But this on-map click could, for example, take the lat long and trigger a new camera position state or modify anything on our application. We have a lot of listeners. Here would be the map long click. So, for example, a map long click could add a marker if we need to. And yeah, this is how the final API looks like. As you can see, with many Compose APIs, it's large. But there are a lot of default values, so we don't need to specify all of them. As following the Compose API guidelines, the first attribute is a modifier with a default value, so we don't need to specify our own modifier. We have also the camera position state, also with a default remember camera position state. So again, we don't need to pass anything here. And the Google Maps option factory, again, with a default one. And here we are going to have all those listeners also set up by default as null. In fact, if you take a look at this API, I think everything has a default value. So you could just call Google Map and it will be initialized. If you need to start adding things like, I don't know, those properties or one listener, you can do it on a one-by-one basis, not with implementing or declaring everything by default. And yeah, the map click listeners internal in the map have look like this. We also have a remember lambda. So this remember is going to make sure that if anything changes, we need to update it. It can be because we can decide to pass a new listener at any time while the map has been already created. And well, these are the entire list of listeners that we have. Those are the ones that we're passing as parameters. And those are the internal ones that the map actually has. Now, there are a lot of possible things that we can do with the map, but let's take a look at how to add the markers, which I guess is the most common one. This is very similar for polylines or any other thing that you might clustering, any other thing that you would like to do on the map. And Google Map accepts a content, which is a lambda, just like a column, for example, or a row. If you have been using a column or a row in Compose, they have a lambda where you just can pass the internal content. So these help us to add markers declaratively. Here we have Google Map passing a marker as internally inside the content. And then if we want, for example, to place a list of markers, it would be as simple as this. We have a list places for each of them, create a new marker using the lat and long from the place that you have just extracted from the list. And yeah, this is the marker implementation. As you can see, it's similar to the previous one in Google Maps, but with the specific things that we require on the marker. We have like a marker state also, because the marker also can have an state that can change. We have things like the alpha, the anchor, the info window that appears when you click on the marker, the icon, title, and also a lot of listeners for interoperated with the marker. The markers make use of this map applier in order to get inserted inside the map. Again, the map applier is the responsible of going to the tree of the recomposition and start adding or replacing things. How do we add a marker in the view system? We call map.addMarker. Now, in Compose, because we cannot call this thing, the map applier takes care of this transformation. Map applier has access to the map, then the map can call that marker, and then we start passing all the different attributes that we need. So content description, alpha, et cetera, et cetera, et cetera. All the previous ones that we saw before. And from the Compose side, what we have is from the view side, we have this add marker extension function that, basically calls in the internal add marker function and passes a marker option function based on the ones that you receive here. Now, the remember pattern is not just for creating map views, but is essential. For example, the width or the color. This is the standard modifier for Compose. We could have a camera position state, which is a parameter of Google Maps. And inside in the content lambda, we could just add a marker or a polyline or whatever we want. So a bit of a checklist here. When we are going to interact with a non-compose target, we need to identify what is this. It's a web view that has strange requirements. It's a custom chart, for example, that is drawing a lot on the canvas, and we need to be observant or something very specific. We need to make sure that we are assessing the lifecycle needs. This is very important because Compose doesn't do it directly. So generally, with this lifecycle observer as a mechanism, we can hook it up with underlying SDK. We always need to bridge it with Android view, meaning we need to host the view inside this composable using the factory method, the update method, and release method. We need to manage the state by using remember, where we need to use it, and state holders. And we also need to create a declarative API. We need to think of, okay, this was my old API using the XML approach, the view approach, and now this needs to move inside my composable interface. What do I need to move, and how do I need to move it? Again, in order to learn a little bit more about APIs for Compose, I would recommend you to take a look at the API guidelines. They're really good at providing some ideas. Some architectural considerations. Performance. Android view can be a performance bottleneck. It's very easy to do mistakes with recomposition, so you need to be careful about how you're doing it. As you know, in Compose, if you are not minimizing recompositions, it can become a problem at some point. You need to make sure that you're capturing all the user interactions. So go through the previous API and see, like the old way, maybe writing in a notes, what are the things that you need to map into the composable, and you need to test the underlying view separately from the composable. There are two different things. Compose is not going to replace any test that might be happening on the view. Performance considerations. This, in general, can be a bottleneck. The interoperability between Compose and the view system is not without cost. In fact, for Android Maps Compose, there is a very old issue that talks precisely about the performance problems. When you try to load a cluster with thousands of items, it's not really working very well. Since the Android view, seems to have like a penalty overhead for performance. And when you're calling it over and over and over, the performance degrades quite easily. The recomposition in general is expensive, so you need to be very strategic about it and taking individual choices of, do I really need to recompose this? Can this stay statically without being taken into consideration by the recomposition tree? That's an engineering decision that you need to take. And you also need to be mindful of complex view hierarchies, especially if you're inside a lazy column on a lazy row, you are scrolling down, the content might be reduced, and this can, again, impact your performance quite heavily. If you want to optimize the performance of Android view, you can minimize the recomposition. So, for example, you can pass only the necessary state to the Android view update block. Just remember when you can. That's why it's being used also in the map view and the camera position state. Avoid the Android view in a lazy column or lazy row. Sometimes might not always be possible, but if possible, this may be a decision that you want to take. And in general, you can use in Android Studio the layout inspector and the profiler to see where the performance bottlenecks are happening. There are more features that you can check. I didn't showcase them here since I don't think they would be telling anything new, but there are things like polylines, advanced markers, Street View, UI and widgets specific for Android Maps Compose. Most of the things that happen on the underlying framework on Google Maps are supported by Maps Compose. And there is also support for Android Maps utils. If you haven't used it before, it's a facilitation library that gives support for things like clustering or a heat map or a few other things. So you don't need to implement them by yourself. Some future work. There is right now an Android Maps utils rewrite happening, another one for Android Maps Compose. So hopefully in the future, this can be used also in the KMP world, meaning this can compile for iOS, maybe another platform, who knows. But yeah, this is, I guess, what the future is bringing. A final thought. We don't have to choose between using a modern UI toolkit or just a mature ecosystem of libraries. We can bridge them by using interoperability with them and Android View. And the techniques we have discussed here are the way to go. We can think about, as mentioned, about the lifecycle, creating the specific Compose API, but it's possible to use not compose UI or a not compose library inside a compose context. There is no need to do either one or the other. So I hope you have learned at least one new thing today. If that happened, I would be very happy. I don't have a lot of social networks. I'm trying to close all of them, but for now, those are the ones I have, one on Mastodon and the other one in Blue Sky. The one in Blue Sky is not me, it's the Kotlin Weekly, mailing list I run for Kotlin topics. And yeah, if you have any question and I happen to know the answer to your questions, which doesn't happen all the time, I would be happy to discuss them. Thank you very much.
Actually, we have some questions for you. So there are actually two. So one is still thinking that the map performance on Compose is much worse than on XML.
Well, it seems, I also think the same. And if you want to check the issues on Android Maps Compose, this is still active, and from time to time get a comment. It has improved over time, also because the compose performance has increased, but it's a bottleneck. That's no question about it.
Okay. And I'm wondering, why is the map composable, not written from scratch in Compose?
The entire map, well, I haven't seen the internal code, but from what I have heard, it's a huge monster written in, it has like a lot of C++, NDK. I can imagine it's large enough to drag a lot of resources.
But there must be really huge test coverage already present, So for AI, it might be, quite easy task instead of doing this really extensive bridging work, which you presented. It's for me as an outsider, like keeping this beast coming is something really.
I don't have internal perspective, but what I have heard after contributing and listening things is that that's off the table and it's not being discussed. In fact, Google released recently or last year the Android Maps 3D, which is also a monster library. It needs like a lot of local configuration to get it running, and it has been done using views. It's not using like Compose at all.
Interesting. Okay, and the last one, are you planning to support Compose multi-platform? WASM target would be nice.
So yes, it's part of the KMP rewrite for Android Maps Compose. The timeline looks like the following. First, the Android Maps utils are going to be rewritten because it's part of the foundation for Maps Compose. This is going to be supporting Kotlin and Kotlin multi-platform, not Compose yet because it's not very heavy on views. And when that's released, then the new Compose rewrite is going to hook on Android Maps utils and offer Compose support. So probably this year, I guess.